and today we're going to talk about something which doesn't necessarily get used all too often by beginners, but it's a very, very powerful feature of the Unreal Engine, and that's path tracing for projectiles. So when you have a projectile, you obviously have a velocity and speed, and it would be good to be able to predict where exactly the projectile is going to go. And this can be used, as you can see here, for arrows, which is very useful, and also for things like where explosions are going to land. And also this means this happens on block as well. So essentially the goal today is to recreate this actor, where I'll play it one more time, is where as the projectile strength grows, then the path is traced to a particular node where the explosion, whatever, is going to happen. And then we have this beam in the center here, and this is being drawn by our path tracing tool. Essentially what we'll have at the end is the ability to add something like this to your actors. I've also included a demo project with this as well, and you can find a link in the description. That basically has a UE5 project with this built into it, so you can just put it straight into your game. And I've also included another couple of actors as well, just containing really useful things which don't necessarily get used by beginners, but are really, really powerful elements within the engine. So what we're going to do is we're going to create these three elements. We've got our blueprint, which controls the projectile and drawing the path. We've got a Niagara effect, which basically draws the path that we've created so that the user can see it in real time. And then we've got an explosion effect, which sits on the end of the projectile. So let's get going. So again, I'm going to build this from scratch, but it's all available there in the demo content project. So if you don't really fancy watching this video, you'd rather sort of go in and learn it yourself, then feel free just to go and download that, and you can start playing around it with yourself. So we'll call this projectile underscore demo. Okay, it's over here. So we'll close this. So the first thing we want to do is just add a static mesh. So in this case, I've just got an arrow. Same game, got an arrow. That was G in case you don't know that shortcut. It just hides all the like collision boxes and stuff like that, just so you can see how something will look in game. It's really, really useful. So on static mesh, I'm going to find this. Cool. And I'm going to make sure we're aligned in the X. The X is the red axis. Okay, great. So next we're going to add some projectile movement. And this is essentially what we're drawing our trace from. So I'm going to put the initial speed at 500, max speed at 5000. And we're also going to add a sphere component. And this will just sit on the root. We don't want it to sit on the actual sphere. And we'll call this input. Cool. Mr. Arrow. Great. So firstly, we just want to make sure that our collision for our static mesh and for our sphere is turned off. Otherwise, we'll be blocking the projectile movement. We can get rid of begin overlap. We do want a tick, and we also want our begin play. So the first thing we want is to know how much power we're putting into our particular projectile. So just create a float called power. I'm going to create an event. Timer. Custom event is add power. I'm going to have this going every 0.01 seconds. Get the power, add 0.01, and I'm going to set power. Okay, great. Cool. So that's looping as well. So we've got our two meshes. both with collision turned off. We've got projectile movement, and we're adding a power variable. Great. So what we want to do is take our power, and we want to get the direction of travel that we're moving in. So we'll do actor forward vector, and then we'll take from our projectile movement, we'll take our initial speed. Great. Times our forward vector by our initial speed. That will say how much we've got to start off with, and then we're going to times this by times this by the power. Great. So now we've got an amount. We just need to draw a trace from this. So we'll do projectile trace. And we've got this node. This is predict projectile path by trace channel. It's actually tracing on the world dynamic as well. So you just want to make sure if you're tracking blocks that they're being blocked by world dynamic. This will go into a tick. And this will be our launch velocity. And actor location. That will be our start position. Great, and to be honest, that's the base of it. That's 100% the base of it. So we'll just draw a debug for one frame, and we'll put this into the world so that we can see what's what. Make sure that's all working okay. Cool. I'm just going to hide the sphere because we don't need that. Endpoint. Hidden in game. Okay. Now come on. Oh, there's our actual one. That actor's gone. Where's my actor? Oh. Okay. Let's take our endpoint out for a second. Okay. Okay. So one thing to note is just on the here we do auto effect variant. We'll take out the endpoint. Do activate. So usually when I'm doing this, the reason that confused me slightly is because I'll do it on the player that has a projectile attached. So for instance, on my particular player, so I'm actually calling the projectile, attaching it, and then I'm increasing the amount on the projectile, and then I'll release. So it is actually a projectile that we're using. That's just something to make sure you're aware of. So as you can see, what we've got now, I'm just going to bring it down very slightly, make it slightly easier, and we'll decrease the minus 1.5. Just make things slightly simpler to start with. So what we've got is we've got path trace that's basically looking at the projectile speed times the power, and bear in mind that the power starts off at 0, and then we're creating these balls. These balls are all equidistant. And what we're going to do now is basically draw a spline across these points. One other thing to note, as you can see where it's red, that means that it's a blocking hit, and there's obviously this is tracing on a dynamic channel, so you can use this as your endpoint if it's a block, and if it's not, then we'll do something else with it. Great, so yes, now that we've sorted out our little issue, let's go back. And one thing to note is that when you go to fire, custom event, we'll call this fire. What we're going to do is just activate that. That will essentially mean that we turn it on. One other note as well, so it will just be we want to use this as our velocity. Great. So this. We'll get projectile movement. Velocity. Set velocity. Cool. Into activate. Nice. So now when we fire, it's basically going to be using the same path that we were tracing before. And you can call this from wherever, if you're using UI or if you're using it as a projectile on your character, then you can call it from your character. Alright, great. So now we've got a bunch of different points. One thing we need to do is, so on our arrow, we want to add a spline. We'll call this points. There we go, that's fine. And on our points, want to add points. No, it's not right. Line points. Set spline points. There we go. Great. Now that will give us a variable of locations of those different balls along the path, and they will be in local space as well. If forever you need to switch it to world space, maybe you're using very, very large coordinates, that's fine. And update as well, that's fine. I don't think we need to change that. So the next thing to do, now we've got our spline points. Our splines are invisible by default, so we need to have something which highlights those points. Yeah, so let's do that first. So just go and create a Niagara system, and we'll create a dynamic beam. This is fairly easy to do, so we'll call it spline effects. Okay, so now we have a beam. Essentially a beam is just, when it's not set up immediately, it's just got a beam end which is 200 on the X. That's not quite what we want, so we're going to switch this to a user parameter. And this will just mean that we can set basically wherever we want to end for our blueprint. We're also going to use tangents as well, so if you choose tangents, that just means that you can put a curve into it, which is exactly what we want. So you'll have a curve coming from the start and a curve coming from the end. So we're going to choose, again, user parameter, and the beam end tangent, user parameter. Okay, the beam start comes from the simulation position originally, which is fine. We can leave it. The reason you wouldn't do this is maybe the projectile was firing from a different location. I think we will set this via user parameter, just because if we need to change it or debug or anything like that, it's a little bit easier. Great, so I'm just going to change the names slightly, just to make them slightly easier. So press F2, so we'll go end, F2 to change the name, start, we'll call this end underscore T. Start underscore T. We're going to double check. Oh. That's F2 again, just to rename it. Oh, didn't like that. Start. It doesn't matter. Okay, we'll just remember that start T has lowercase. I'm just going to make sure. Yeah, so this one's actually wrong anyway. So it's their beam tangent, the actual. There, otherwise we'll just be choosing a vector which isn't really what we want. So we're going to user. Cool. Okay, we'll go ahead and change that name again. Confusing there. Okay. 2 is not working for me for some reason. Start T Not doing too well. TN. Start TN. That's fine. I'm just gonna get rid of that one. There's no use. Can't remove it. How do I? End tangent, start tangent, beam end, and start. I'm going to do absolute start and absolute end as well. That's absolutely fine. Great. So we're spawning 100. One thing I would suggest to do is rather than let all the particles finish and then kill emitter, we want the emitter and particles to die immediately. This means that when you fire it, it just disappears rather than having to wait. Cool. So let's see where we're at. So we've got our spline points now. What we want to do is we want to get the location of distance. We want to get a spline point. So 0 is our start, and that's where we want to set our start on our spline effects. So if we browse to spline effects, and then on our points, just add a Niagara particle system. Call this spline effects. Great that we've already got all of these, so we can see our override parameters here as well, which is very, very useful. I'm just going to call this and say set vector parameter. That's great. And so at the first point, which is our index 0, we want to get the name, which is copy display name. Paste, start, put it start, and I'll put the tangents in between in a second. So we'll want to do a quick test, make sure everything's okay. Copy display name, delete this one, talk amongst yourselves, paste. Cool. So for this, this is quite dependent on what you want exactly. So what I'd suggest is that if you're doing a small spline, then you can always put your endpoint at the endpoint. If you're doing a bigger spline, where you might be shooting off into the distance, it's more important to get the ones which are closer to you. So I'd recommend either doing the first 4 or the first 6. So you go 2, 4, 6, 8, whatever. Just something to be aware of, that if you're drawing it too far, then your line will flatten out, and that may not be the look that you're going for. So just a word of caution there, especially if you're shooting an hour along it or whatever, then it obviously needs to be pretty exact, so the closer you can get, the better. Cool, so we're just going to copy and paste this one again, get the point index, so now we're setting the start and the end on the spline FX. Great, this needs to be plugged in to our points. Okay, it should theoretically work. I'm just going to turn off this debug. Here we go. So one thing we are seeing is that we're dropping out, so we just want to make sure that you put the duration of the actual emitter just up. So here we go, so I'll put this at 10. Doesn't really matter if you get a bit of an overlap because you're constantly changing the location of it anyway, just make sure that never goes dim. Cool, and we are slowly but surely drawing it. Very good. So just on the beam width, at the moment we've got a bit of a curve going on. We can take that out, or you can do whatever you like really. So you could do a curve like that, for instance, which will mean that it just is fine, and then it goes very, very small at the end. But I just want to take this out entirely and just do a single beam width. That's fine. Cool. So now we have. I'm just going to beef up our power a little bit. one. And I'm just going to turn it as well. Cool. So we have our arrow, and dependent on the location, we're going to be changing the location at the end of the point. That's just a line trace, so let's make it a bit more fancy and add in the tangents as well. Yeah. Cool. So for this, I want to get a couple more of these nodes. Very good. I'm not going to put it at the end spline point. I'm going to put this at 2, at 4, and 6. Cool. Give us a nice curve. Plug this one back in. Very good. And set some more parameters on our system. Hope I haven't made the naming convention too complicated myself. Let's set that location in there, that location in there, and I'm going to connect these up as well. Cool. Great, so let's look at our naming. We go end tangent. Let's put this one first. Start tangent and end. Oh, not entirely sure what I did there. Sorry. End tangent. Great. Cool. So now we should get a nice little curve. Oh, what's going on here? What did I do? Start, that's the end. So it's okay. Yeah, there we go. Just make sure you tick the absolute start and absolute end, otherwise it will try and find some funky curves for you, or do some all sorts of stuff. And it's very cool if you want to get like a sort of a bendy kind of effect, but that's not really what we're going for. And the splines will, depending on where you end up, they will glide into you, which is great. So finally, we just want to set a nice effect on the ball, and then we want to move the ball depending on the speed. So this is perfect for things like explosions and stuff like that. Very, very useful. So let's make it from scratch. It's quite a simple material. We'll call this explosion material. Okay, now we're just going to get colour, any colour you like. Let's do blue, seems like blue. Let's do well. Green in there as well. Add this to our emissive. On this, we want to change this to translucent as well. And we want to get Fresnel node. Fresnel just means that you light up the vertices basically, and then put that into opacity. That will give us a nice cool effect. I think we just want to times these 2 just to get a little bit more clearness in the actual centre. This is why. Okay, so this needs to go into opacity, and this one into emissive. Makes a bit more sense. Should look a bit better now. There we look. Fingers crossed. We'll come back to it. Browse project demo. Put on the endpoint. There we go. Cool. We have a nice, cool blue effect. Looking very, very fancy indeed. Let's see what it looks like in the game. Cool. We are just going to make this slightly bigger, this endpoint. Go 5, 5, 5. Looks about right to me. And now what we want to do is we want to move this endpoint based off of this hit location. So we just go here, we break it. Now we've got two different options. Two possibilities. Either we get a blocking hit, or we don't get a blocking hit. And depending on this, we want to have different outcomes. So let's make that happen. So first of all, we want to set as default hidden in game. Because it's on tick, you shouldn't necessarily see this anyway, but just in case it isn't activated, it's good practice. And then we want to set. We will do world location. I'm pretty sure it's world location. It might not be, but that's fine. So I'll just do this to demonstrate. Essentially, what the problem that we have is we will set this as hidden, not hidden in game. So hidden in game to not hidden. Okay, cool. So as we can see, we are moving the ball, and that's all very well and good. However, as and when and this is because we're getting a blocking hit, by the way, so depending on where the hit is, that's where the ball will be. But as you are about to see, once it stops being a blocking hit, and we can no longer move our ball, it doesn't work when we're not actually doing a blocking hit. Which is fine, it's not necessarily such a big deal, but it's something to be aware of. So we want to do an additional check. Do a branch in here and see whether this is a blocking hit, and if it is, then we'll set the world location and so not hidden in game, and if it's not a blocking hit, then I'm just going to choose to hide it. Cool. So that means it won't constantly be trying to draw it or give me bugs later on down the line, so definitely worth doing. Okay, cool. And that's pretty much it. That's our projectile, which we created, which is then drawing, so increasing in power, drawing a trace channel, which is on the world dynamic, and on that trace channel we have got a nice cool effect for an explosion, where our explosion or actor is going to be. And yeah, it's basically a very, very useful tool. You see lots of AAA games doing things like that, so when you're playing throwing grenades, stuff like that, it's used all over the shop. But again, not many beginners know that it exists, know how to use it, and it looks great. It looks really, really good. So again, in the details, I'm going to leave access to a project, which basically has, so just in the map which opens on that project, there would be this actor with all the code that you've seen here, and materials and stuff, and I've also included 2 other actors which don't necessarily get you, or 2 other pieces of code or tools which don't necessarily get used too much by beginners but are really useful. Rather than making a tutorial, I figure it's best to just sort of send it to you so that you can see them yourself, have a play with them, see whether you can bring them into the game. You'll know exactly what those other tools are. One is a physics constraint, so that means that you can make things sort of like hang and stuff like that. I've added some a target in there, which means that it's got some scoring on there as well, so I see whether you can set something up to shoot it. And I've also added a predictive jump node or predictive velocity node, which will basically fire characters to specific locations without you having to do any code or testing, pretty much anything like that. So go in there, check them out if you want to. It's absolutely free, no problems. If you've got any questions or if there's anything else that you want to know about in regards to this project, anything that you want me to sort of do a tutorial in terms of how did you do that, then yeah, that's certainly possible. Cool. Otherwise, thanks very much and all the best. Bye bye.